Ever wondered why 5G is faster and smarter than 4G? Today, we'll explain 5G network architecture from RAN to core in simple terms. Let's start with why 5G is different from 4G. 4G uses macro towers and a centralized core. It's good for video and browsing, but has higher latency and limited device support. 5G is completely different: dense small cells, virtualized core, and network slicing. That means faster speeds, ultra-low latency, and millions of devices connected simultaneously. Think of 4G as a two-lane road. 5G is a superhighway with dedicated lanes for video gaming and Internet of Devices. Next is RAN, Radio Access Network. This is how your device connects to 5G. The 5G tower is called gNodeB. It has three main parts: Kube N, Dua arms, Ru R Nen. CU handles decisions, Do processes data. Ju connects to your device. This setup allows more users, higher speeds, and better coverage than 4G. Next, the transport network connects RAN to core. It's mostly fiber, carrying huge amounts of data quickly. Fronthaul connects LY2 to do short distance, low latency. Backhaul connects due to core, high capacity, longer distance. Think of it as a high-speed highway for all your data. 5G core, AMF, SMF, UPF. The 5G core is the heart of the network. It manages users, sessions, and data routing. Main functions: AMF manages device connections, SMF manages data sessions, UPF moves user data packets. Unlike 4G, 5G core is cloud-based and virtualized, making it flexible and scalable. Let's compare NSA versus SA. NSA speed is medium and SA speed is high. NSA latency is higher, while SA has low latency. NSA has early deployment using 4G, while SA is full 5G structure. NSA uses old 4G core with 5G radio. SA is pure 5G, full speed, low latency, and advanced applications. 5G powers YouTube streaming in HD instantly. Gaming, ultra-low lag for cloud, mobile games, IoT devices, smart homes, smart cities. It's not just speed, it's reliable connectivity, low latency, and massive device support.